Okay, so today we're going to move on with our trig stuff, and we're going to talk about reciprocal functions. Now, we've said reciprocal multiple times this year, but I'm going to give you just a definition. Honestly, I could give you a very confusing definition, but I'm just going to tell you this. A reciprocal is a flipped fraction. You flip a fraction, okay? So your example here, what's the reciprocal of 4? Remember, 4 is really 4 over 1. So the reciprocal of 4 is 1 over 4. Then if I ask you for the reciprocal of 1 over 4, you would get 4. So it goes back and forth between the two, okay? So now what we're going to start talking about today are reciprocal functions. Now, in geometry and so far in advanced algebra or any other classes that you probably took, you've probably seen only sine, cosine, tangent, right? 3 trig functions. There's actually 6, okay? You only have 3 on your calculator. You only need 3 on your calculator. The other 3 come from the reciprocal functions. So the reciprocal of sine of theta, is 1 over the sine of theta. That has an actual name. The name of that is I'm going to write it out, but it's cosecant theta. Cosecant of theta. Okay, there's one for all of them. So the reciprocal of cosine, these two things are equivalent. These two are equal. That's not equal to the sine of theta. That's the reciprocal. That would if you were to say that sine of theta is the same thing as cosecant of theta, that's like you saying that 4 is the same thing as 1/4, right? Remember, they're reciprocals. They're not equivalent to each other. Cosine of theta, the reciprocal of cosine of theta is 1 over the cosine of theta. That name is the secant of theta. So you have cosecant and secant. And remember, that's not equivalent to the cosine. It's just the reciprocal of it. And then the last one is tangent. This one's easier. The reciprocal of tangent is 1 over tangent theta. And that is cotangent of theta. Cotangent. So the way that I remember it, tangent and cotangent, those are the easy ones. But sine going to cosecant and cosine going to secant, the way I remember it is that the letter flips. I know it sounds kind of silly, but honestly, this is what I do. So sine, right, starts with an S. So it's reciprocal, starts with a C. It doesn't start with the same letter. I know it sounds ridiculous, and then it works too because cosine starts with a C, so it's reciprocal, starts with an S. Okay, the letter flips. All right, anyway. So the questions that you're going to be asked based off of the reciprocal functions, you're going to be asked where the reciprocal functions are positive, which is kind of like what we did with the other 3, right? And then you're also going to be evaluating reciprocal trig functions. So let's just start with the first part. Where are the reciprocal functions positive? If you remember, I gave you that phrase, all students take calc. And that says where everything's positive and negative, right? So I'm not going to write sine, cosine, tangent. I'm going to write the reciprocals. I'm going to write cosecant, secant, and cotangent for all of them. Okay, and this goes in that order. Okay, so I just filled that in. If you want to pause the video to fill that in now, feel free. So we are going to put, based off of this phrase, all students take calc, we're going to make the reciprocal functions also positive and negative. Now remember, a negative reciprocal is different than a reciprocal. I know you're all trained in geometry to do negative reciprocals because of perpendicular lines having negative reciprocal slopes. But here it's just a reciprocal. So if it's positive, it stays positive. If it's negative, it stays negative. You're not changing the sign, okay? So in the first quadrant, all 3, right, that's what the A is, all. sine, cosine, tangent, they're all positive. So because all of them are positive, that means that all of their reciprocal functions are also positive. Okay, everything in quadrant 1 is positive. In quadrant 2, the S stands for sine. Only sine is positive, which means that if sine is positive, cosecant is positive. Also, if only sine is positive, that means that cosine and tangent are both negative. If cosine is negative, secant is negative. If tangent is negative, cotangent is negative. Okay? In quadrant 3, only tangent is positive, which means that the reciprocal function cotangent would be positive. If sine is negative, cosecant is negative. If cosine is negative, secant is negative. And in quadrant 3, the C stands for cosine, which means cosine is positive, therefore secant is also positive. And the other two are negative. Okay? So these questions over here, we're going to answer based off of that chart. So if you want, I'm going to show you different ways you could do this. If you want to keep this chart in front of you and just find which quadrant it lines up in, you can do it that way. But if you remember, all students take calc, I'm going to show you what you can do also. So secant of theta greater than 0. This is how I process it. Secant is the reciprocal of cosine, right? Greater than 0 means positive. So let's just do that part, right? I'm going to set up this chart. This is how I did it the first time I showed you how to do this. Cosine is positive in the A, and in the C, in all students take calc, right? So it's cosine is positive in quadrant 1 and quadrant 4. Okay, perfect. Cotangent of theta is less than 0. The reciprocal of cotangent is tangent, and less than 0 is negative. Okay, so cotangent of theta is less than 0 is the same thing as saying tangent is negative. Tangent is negative in quadrants 2 and 4. So because quadrant 4 has both criteria, your answer is quadrant 4 for number 1. For number 2, cotangent of theta is greater than 0. That's the same thing as saying tangent is greater than 0 or positive. So if I make my chart, tangent is positive in quadrant 1 and quadrant 3. The second part, cosecant is greater than 0. Cosecant is the reciprocal of sine. Greater than 0 meaning positive. Sine is positive in quadrant 2 and quadrant 1. Because quadrant 1 has both check marks, my answer is quadrant 1. Okay, and then the last one for this. Secant of theta, the reciprocal of secant is cosine. We have less than 0. Less than 0 is negative. Cosine is negative in quadrants 2 and 3. Cosecant of theta is the reciprocal of sine of theta, greater than 0 meaning positive. Sine is positive in quadrant 1 and 2. So because quadrant 2 gets both of my checks, my answer to number 3 is quadrant 2. Okay? So again, you can either do it that way, or if you want to rely heavily on this chart, I know you guys have all of this stuff in front of you whenever you're doing your homeworks or your tests or anything like that, so feel free to use it. Just keep in mind that next year you're going to have to know how to do this without using the chart. Okay, you have to kind of know the chart in your head, and that's why I teach you all students take calc. Okay, and then this bottom part, evaluating reciprocal trig functions. So like what we did the other day, but now with evaluating. So this is what you're going to do. First, you are not going to evaluate the reciprocal trig function. You are going to evaluate, meaning you're not evaluating, you're not going to plug into the calculator cosecant, secant, and cotangent. There's no button on the calculator for that. So instead, you are going to evaluate its reciprocal, meaning you're going to either do sine, cosine, or tangent, depending upon which one it asks you for. Okay? So you're going to evaluate just like we did the other day. So if you have to change the radians into degrees, or if you're switching the calculator mode, whichever way you want to do. Step 2, once you evaluate that, you're going to flip your answer. You're going to flip the fraction. Because again, you evaluated the reciprocal, so you have to flip it back. And then step 3, you may have to rationalize the denominator and simplify. But not always. So we'll write if necessary. Okay? So let me show you some examples of that because I know it's a little weird. So for number 1 down here, I ask you evaluate the following trig functions using exact value. So those are those 4 decimals. So if they're not in front of you, I suggest you go get them if you don't know them. So number 1, I'm asking you for the secant of 4 pi over 3. The secant of 4 pi over 3, the reciprocal of secant is cosine, right? But you know what, before we do that, let's get rid of the radians because I think that's what most of you are doing. So this is in radians, we're going to put it into degrees. So to put it into degrees, we're going to do 4 times 180 divided by 3. 4 times 180 divided by 3 is 240 degrees. So you can think of this, instead of this asking for the secant of 4 pi over 3 radians, let's say it's the secant of 240 degrees. Again, it's the same thing, just asked in a different measurement. Okay? So in order to figure out the secant of 240 degrees, we have to figure out what is the cosine of 240 degrees. So that you plug right into the calculator, and that gives you negative 0.5, or negative 1/2. I don't want the cosine of 240. I want the secant of 240, which is the reciprocal of the cosine of 240. So the secant of 240 is the reciprocal of negative 1/2. So you flip this fraction here to be negative 2 over 1, or just negative 2. All right? I know it's a little weird. Let's look at number 2. You'll get the hang of it, I promise. Cotangent of 135 degrees. So we're in degrees, right? So I don't have to change the mode unless you're switching back and forth, right? I'm in degrees, which is where I prefer to be. The reciprocal of cotangent, I cannot type a cotangent into the calculator. I can, however, type its reciprocal in, the tangent of 135 degrees. The tangent of 135, you can type that right into your calculator. That gives you negative 1. So I don't want the tangent of 135 degrees. I want the cotangent. So I want the reciprocal of negative 1. The reciprocal of negative 1, this is a little confusing, is negative 1, right? Negative 1 over 1. If you flip that fraction, that becomes 1 over negative 1, which is really just negative 1. Okay? So number 2 is negative 1. Number 3, the cosecant of 45 degrees. So 45 degrees, I'm in degree mode in the calculator. I cannot type cosecant into the calculator. I can, however, type the reciprocal in. The reciprocal of cosecant is sine. So if I type the sine of 45 degrees into the calculator, that gives me 0.7071, but that's one of our special decimals, right? 0.7071 is really the square root of 2 over 2. I don't want the square root of 2 over 2. I don't want the sine of 45. I want the cosecant of 45. So I flip that fraction, and this is now 2 divided by the square root of 2. I'm going to come down here for a second, though. Step 3, I told you to rationalize the denominator. Rationalizing the denominator means that you do not have a square root in the denominator of a fraction anymore. So we have to get rid of that square root in the denominator. And you can't just erase it. You have to do something that actually gets rid of it in a mathematical sense. So this is what you do. You multiply the top and the bottom of the fraction by whatever that radical is. In this case, the square root of 2. So 2 times the square root of 2 is 2 square root 2. And the square root of 2 times the square root of 2, the radicals cancel each other out because it's kind of like doing the square root of 2 squared, right? The radical and the 2 cancel each other out. Now, 2 and 2 will cancel out, and you're really just left with the square root of 2. Okay? So cosecant of 45 degrees is equal to 2 divided by the square root of 2, but then you rationalize that and you clean it up, and you get really just the square root of 2 as your final. All right? And then the last one, number 4. Almost done. Cotangent of pi. So first of all, I'm in radians. I'm going to change that into degrees. So I would replace the pi with 180, which, done, right? So I can't type cotangent of pi in, or cotangent of 180 in, but I can, however, do the tangent of 180. If I type tangent of 180 into the calculator, I get 0. Okay, let's call that, just for a second, let's call that 0 over 1. When you go to take the reciprocal of that, because I want the cotangent of 180, not the tangent, that becomes 1 over 0. And whenever you divide by 0, that's undefined. As your answer, okay? Make sure you submit your notes. Let me know if you have any questions. The homework will be up tomorrow. Have a great day.